So the nth term of a geometric sequence with your first term notated as a sub 1, obviously that hasn't changed at all throughout all of our lessons. A sub 1 represents our first term. And our common ratio, we talked about this before, is r, can be found using the following rule. A sub n, again we're using a sub n to represent our rule, for a geometric sequence is a sub 1 times r raised to the n minus 1. We have to be careful here because the r is the only value that's being raised to the n minus 1, not the a. So we can't multiply our value for a sub 1 and r together. These two have to remain two separate values. So let's look at example 2 to see how this will look. In example 2, they want us to write a rule for the nth term of the geometric sequence, 32, 16, 8, 4, and 2. And we looked at this before. This was part of our example 1, letter A. So we want to come up with the rule with this sequence. Then we want to find what the 8th term is going to be. So if we look at this, we first want to, so we'll do step 1. We want to find a sub 1, and we want to find our common ratio. A sub 1 we know is 32. Our common ratio is the value or the constant that we multiply or divide by to get to the next term. Since we're dividing by 2, it's the same thing as we're multiplying by 1/2. We find that r by taking the previous or the next term divided by the previous term. And we can look back at example 1, letter A, if we need help remembering how to find r. But your ratio is found by that constant number in between all of them, which is like multiplying by 1/2. So our r is 1/2. So our rule, if we plug in the pieces we know, is 32, a sub 1, times 1/2 raised to the n minus 1. And that whole thing is our answer. We can't take 32 and divide it by, or multiply it by 1/2 or divide it by 2 because these are two separate values. The 1/2 is the only number that's being raised to the n minus 1, so we have to keep these separate. So your answer for the rule is a sub n is equal to 32 times 1/2 raised to the n minus 1 power. To find your 8th term, we're going to plug in 8 wherever n is, so we get 32 times 1/2 to the 8 minus 1. Well, we know 8 minus 1 is the same thing as the 7th power. If I take 1/2 only and raise it to the 7th power, I get 32 times 1 over 128. 32 times 1 over 28. We can do that in our calculator, or we can write this as over 1 and then write this as 32 over 128 as a fraction and reduce it, but it gives us 1/4 as our final answer. So the 8th term is 1/4. And we could keep this sequence going all the way till you hit the 8th term, but if we're looking for the 100th term, that would be very difficult, so the rule comes in handy when we're looking for terms that are much higher than single digits.